Hello friends, in the last class we have discussed about electric current and drift velocity. Today let us deal with Ohm's law. So first question that comes, what do you understand by the law, Ohm's law? Ohm's law. It states that the current flowing through a conductor is directly proportional to the external potential difference applied. The external conditions should remain constant. Means it states that the potential difference applied V is directly proportional to I if I is the current flowing through a conductor. Since proportionality is there, there must be some proportionality constant. So we will write V is equal to Ri. What is R? R, first of all, we will define according to the equation as constant of proportionality. Proportionality. Second, R is called resistance of the conductor. We will discuss this R elaborately. That should be kept in mind. So we can write R equal to V by I. The ratio of potential difference in current in the circuit is the resistance of that सर्किट एलिमेंट. यहाँ तक कोई दिक्कत नहीं होनी चाहिए, ये सारी बातें आपको समझ में आ रही होगी. फाइन. नाउ what is the external condition? This external condition is to be discussed, and this is the most important and very important while dealing with the Ohm's law. This will be kept in mind. We have R resistance. What is resistance? Resistance is the opposition offered by the conductor to the flow of current. It is the opposition offered by the conductor to the flow of current. Opposition offered by the conductor to the flow of current. That has to be taken care of. One thing. This resistance is directly proportional to the length of the conductor. this resistance is inversely proportional to the cross-sectional area of the conductor. So, combining these two, R is proportional to L by A. And since the proportionality is there must be some proportionality constant, that is R is equal to rho L by A. Again we will define in the same way. This rho, resistivity of the conductor, L, length of the conductor, A, cross-sectional area, of the conductor. That has to be seen. Always keep in mind. What is the difference between resistance and resistivity? That is the main question and crucial part of the thing that has to be taken care of. Resistivity is of the substance. Resistivity is of the substance and resistance is of the object. Mind the word? Resistivity is of the substance and resistance is of the object. कहने का मतलब है ये इस तरह से समझिए मास और डेंसिटी. Density is of the substance and mass is of the object. उस substance से जो object बना है उसका mass है. Mass can vary but density cannot. उसी तरह से resistance can vary, resistivity cannot. That should be kept in mind. इन दोनों clear cut variation रखिएगा. Since this resistivity depends on the temperature, since this resistivity depends on the temperature, resistance automatically will depend on the temperature. That has to be taken in. Now, we can write, can I? Now, the resistivity depends on temperature as rho is equal to rho naught 1 plus alpha delta T, where rho naught resistivity at some standard temperature. Now, delta T increase in temperature. Alpha, temperature coefficient of resistance. Of resistance. Rho is the resistivity at the final temperature. That should be kept in mind that since resistance depends on the resistivity and resistivity depends on temperature, so with the increase of temperature, resistivity increases, so resistance increases. That should be kept in mind. अगर resistance increase होगा, V by ratio भी increase होगा, V by I ratio भी increase होगा. That is Ohm's law. That's why we'll say external conditions should remain constant. External condition means one condition that we have proved here is temperature. So temperature should remain constant. One thing that we will write. Don't worry. We will write. Now, Again, the external condition first, temperature. Second, material of the conductor. Of the कंडक्टर. एक बार यदि कॉपर का ले लिए हैं तो दूसरी बार भी कॉपर लेंगे और वही कॉपर लेंगे. ऐसा ना हो कि एक बार कॉपर के साथ एक्सपेरिमेंट कर लिया दूसरी बार आयरन के साथ एक्सपेरिमेंट कर रहे हैं. दोनों का रेजिस्टिविटी अलग अलग होता है. अगर अलग अलग होता है तो उसके साथ करंट फ्लो भी डिफरेंट होगा. इस चीज को सदा ध्यान रखिएगा. थर्ड, लेंथ ऑफ द कंडक्टर. And fourth, cross-sectional area. Area of the conductor. Cross-sectional area of the conductor. ये चारों चीज किसी भी मटेरियल का सेम होना चाहिए, किसी भी कंडक्टर का सेम होना चाहिए एक्सटर्नल एनवायरनमेंट. इस चीज को सदा ध्यान रखिए. कोई दिक्कत इसमें नहीं होनी चाहिए, है ना. सो द एक्सटर्नल कंडीशन दिस शुड रिमेन कांस्टेंट. ये सदा ध्यान रखिएगा. पहली चीज, टेम्परेचर, मटेरियल, लेंथ, क्रॉस सेक्शनल एरिया. Because the resistance of the conductor are, we have come to know, rho L by A. Rho L by A. Rho L by A कहने का मतलब है, देखिए, resistivity, और resistivity depends on temperature, that's why the word temperature, length, cross sectional area. जिस तरह से रेजिस्टेंस डिपेंड कर रहा है, रेजिस्टेंस इंक्रीज कर रहा है या डिक्रीज कर रहा है, उसी हिसाब से V बाय I का रेशियो इंक्रीज और डिक्रीज करेगा. यहां तक बात कोई दिक्कत नहीं होनी चाहिए. अगर कोई दिक्कत है तो बोलो. नोट डाउन ईच एंड एवरी वर्ड दैट आई हैव रिटन, आई टेल यू. इसमें कोई दिक्कत नहीं होनी चाहिए. कैन आई? Yes. Now, let us deal with the validity and failure of Ohm's law. And of Ohm's law. Conditions. First, Ohm's law is valid Ohm's law is valid at moderate temperature Second, Ohm's law is not valid at very high or very low temperature. Ohm's law is not valid at very high potential difference. Ohm's law is not valid at very high current. That should be kept in mind. These are four criteria where Ohm's law is valid or not valid. That should be kept in mind. This will help you out. One thing, valid at moderate temperature only. Not valid, very low temperature. Not valid, very high potential difference. Not valid, very high current. यहां तक बात समझ में आनी चाहिए. We will see in the graph. We will see in the graph how the things are varying and where the Ohm's law differ with high temperature and low temperature. That also we have seen. ठीक है? Let us see. Material. Can I? The next thing that we are supposed to deal is material. First, Ohm's law is valid only for conducting materials in general we can say metals. Simple. We can say in bracket right metals. Do not hesitate. Do not hesitate in saying so. Second, Ohm's law is not valid for semiconductor like germanium and silicon and insulator. Third, Ohm's law is not valid for alloys. बच्चों ये सारा कुछ अब आपको ध्यान में रखना ही पड़ेगा, जैसे भी रखते हैं. It is valid. It is valid only for conducting material. Conducting material means metal. Metal means iron, aluminium, copper, gold, silver, like that. This sort of material is required. Ohm's law is not valid for semiconductors like germanium and silicon and insulators like diamond, like any dielectric material. Ohm's law is not valid at all. Now, Ohm's law is not valid for alloys. Alloys means alnico, alloys means nichrome. This sort of materials are there where Ohm's law is not valid. Steel, stainless steel. Stainless steel where Ohm's law is not valid. That should be taken care of. Now, How it varies? How it varies from its regular graph that has to be taken care of. Now, let us deal with the graph IV graph straight line. This is for conductor. And here again I am saying the limitation at very high voltage it goes like this. You can see here you can see the variation in the graph. At very high voltage and very high current, it is not going straight line. With a small change in voltage, very high change in current is there. This should be taken care of, and this is the criticality of Ohm's law graph, the VI graph. It's not straight line always. One thing keep in mind. This is on conductor. Or better we write here. Now, IV. For semiconductor, it goes like this is for semiconductor. Semiconductor means germanium, silicon, like that. कोई दिक्कत यहां तक? कोई दिक्कत नहीं होनी चाहिए. ये वेरिएशन इस तरह से क्यों होता है, दैट वी विल स्टडी इन द सेमीकंडक्टर टॉपिक. पूरा डिटेल में करना है, हमारे +2 में ही है, इसका चिंता मत कीजिए. फुल डिटेल में करेंगे, फुल डिटेल में कौन सा इक्वेशन फॉलो करता है और कैसे करता है, इस चीज को पूरा देखने की जरूरत है. नाउ थर्ड वी विल सी IV. It goes like this. This is for alloys. Alloys means nichrome steel, like you can say nichrome. Alnico. This sort of things are there. It is going like this. Main thing is this. Now, one more graph I would like to tell you. That is this is the thing. This is for thermistor and thyristor. And बच्चों, ये क्या होता है, कैसे होता है, नहीं होता है, उसको हमको देखने की जरूरत है. थोड़ा सा हाई लेवल में जा रहा हूं और कोई बात नहीं है, इस चीज को ठीक ठीक समझिए. आप देखेंगे सारा ग्राफ हमारा स्ट्रेट लाइन नहीं है, सब वीआई कर्व हमारा स्ट्रेट लाइन नहीं है. इसीलिए हम लोग ओम्स लॉ को कभी भी यूनिवर्सल लॉ की तरह नहीं देख पाएंगे. ठीक है. ड्यू टू द लिमिटेशन, लिख लो कंक्लूजन. ड्यू टू द लिमिटेशन, Ohm's law is not a universal law. Okay. But this law is valid at moderate temperature and moderate condition of the environment. So it's very, very practical. But Ohm's law is very practical at moderate condition. That should be taken care of. In the next lecture, we will elaborate this in a different way. We will find a different expression for Ohm's law. We will find the different way of finding the temperature coefficient of resistance. हम लोग दूसरी तरीका से चाहेंगे कि Ohm's law को very fundamental और minute अंदर ले जाए. J is equal to sigma E. What is current density? What is sigma? What is how it varies? ये सारा कुछ हमको रिलेट करके Ohm's law को फाइनलाइज करना है. Thank you very much.